Hey, it's Miss Johnson here, back to give you our video for Unit 7 Notes 5. Today we're talking about mutually exclusive and inclusive events. Let's start with our example up at the top. We have a bag of 8 red marbles, 12 blue, 9 yellow, and 11 green marbles. We're supposed to find the probability that either a blue or a green marble is chosen. So either blue or green means that I'm looking for, obviously, blue or green. First thing I need to know is how many marbles are there total. We have 8, 12, 9, and 11. 8 plus 12 plus 9 plus 11, that's 40 marbles. So there's 40 total. The other thing I need to know is how many are blue and how many are green. For the blue, I have, where are they? There they are, 12 blue, and for the green, I have 11. So if I look at those two together, the probability of getting a blue is going to be 12 out of 40. The probability of getting a green is going to be 11 out of 40. And if I put those together, that means it's 23 out of 40. That's my probability. We could leave this as a fraction and reduce it. Here there's nothing we can reduce 23 and 40 by, so it would just stay that way. Or you could make it a decimal if you wanted to, but you don't have to. Now, thinking about blue and green marbles, assuming that all of our marbles are just one color like they are in our bag down here, that means that a marble can't be blue and green at the same time. So that means that they are mutually exclusive. Okay, mutually exclusive. Mutually exclusive events are events that do not affect each other, such as rolling a 5 and flipping a tails on a coin. There's nothing on a die and a coin that can be at the same time because they're two different things. Rolling a die is the numbers 1 through 6, flipping a coin is heads or tails. So if I were going to find the probability of mutually exclusive events, events that don't affect each other, that means I'm looking at the probability of the first event plus the probability of the second event. Now, on the flip side of that, if we look at inclusive events are events that do affect each other. Okay, events that have something in common. So one example might be rolling a number less than 3, so that would be 2 or 1, or rolling a 1. Well, some of those things overlapped. So I have the probability of A rolling a number less than 3, which is 2 out of 6. The probability of B rolling the number 1, which is 1 out of 6, and subtracting out the probability of them both. That's the inclusive part of it. The ones that are included in both, you have to take away because they were counted twice. So the number 1 was counted in there twice, so I have to take away 1/6. So my probability here would be 2/6 plus 1/6 minus 1/6, which is still 2/6 or 1/3. Okay, so I have to account for the fact that those things were accounted for twice, and I need to take them out. So let's just take a look and practice deciding whether things are mutually exclusive or if they're inclusive. If I look at number 1, drawing a heart or a diamond from a standard deck of cards. Drawing a heart or a diamond from a standard deck of cards. Is it possible for something to be a heart and a diamond at the same time? No, it's not. Those are two different suits. It's either a heart or a diamond. They can't be both. So since you can't be both, there's nothing that's going to fall into both category. That means they're mutually exclusive. Number 2, drawing an ace or a spade from a standard deck of cards. Ace or a spade. Well, there's an ace in all 4 suits, in hearts, in clubs, in diamonds. I still can't draw a club. And in spades. There's 4 of them. And clubs. Since there is an ace in the spades, that means that there's going to be things that overlap. We've got an ace that's in the spade category as well, so I have to take out the inclusive part. These are inclusive events. They're events that cross over each other or overlap. Number 3, rolling a 5 or a number greater than 3. Well, rolling a 5 is just the number 5. Numbers greater than 3 would be 4, 5, and 6. Uh-oh. I've got 5 in both. So again, these are inclusive because there are events that overlap. Why don't you pause the video for now and see if you can answer number 4. Flipping over to the back side, we're going to find the probability of all of these events, but we also have to decide whether they're mutually exclusive or if they're inclusive. In number 5, we're picking 1 teacher out of all of those options. There's 12 math, 9 language arts, 8 social studies, and 10 science teachers. You're picking 1 teacher. What's the probability that it's either language arts or social studies? Either language arts or social studies. So one thing I need to know, or the first thing I need to know, is how many total teachers? 12, 9, 8, and 10. When I add up the total number of teachers, I have 39. Okay, now, if I'm picking one and I want to find out whether it's going to be language arts or social studies, assuming that teachers only teach one subject, which most of them do, these are going to be mutually exclusive events, because if a teacher teaches language arts, then they do not teach social studies, typically speaking. So in this case, I'm thinking mutually exclusive, and I need to find the probability of them both added together. There are 9 language arts teachers, so that's 9 out of 39. And there are, I'm looking for social studies, 10 social studies teachers, so that's 10 out of 39. If I add them together, that would be, oh, I'm sorry, that was science teachers. We're looking for the 8. My apologies. 8 out of 39. So I've got 9 plus 8, which is 17 out of 39. And again, if we could reduce that, we would, or you could make it a decimal, but you don't have to. You can leave it like that. In number 6, now we are looking at 1,400 students, 550 take Spanish, 700 take biology, 400 take both. Both, key word there. So that means that out of the 550 students who take Spanish, 400 of those were also counted in the biology category. So these are inclusive events that we're going to have to take away. So first of all, 1,400 students total. Okay, that's my total number. If I want to find the probability that a student is in either Spanish or biology, this is or, Spanish or biology, then I need to look at the 3 separate probabilities. I have 550 out of 1,400 that take Spanish. I have 700 out of 1,400 that take biology. But again, I have 400 that were counted in both, so I have to take those 400 away. So I'm going to subtract 400 out of 1,400 and figure that out. 550 plus 700 minus 400 is going to be 850 out of 1,400. I can reduce this fraction down to 17 out of 28. Okay, so there's the inclusion part of it. Okay, since there were people that were counted in both categories, I had to take them away because I can't count the same person twice. I want you to pause the video and see if you can figure out number 7 on your own. And let's take a look at number 8. In number 8, it says there are 4 algebra books, 3 literature books, 2 biology books on a shelf. What's the probability that you select a literature book or an algebra book? So first of all, can something be a literature book or an algebra book at the same time? Literature book and algebra book at the same time? No. So these are mutually exclusive events. Since they are mutually exclusive, I just need to look at my 2 probabilities and add them together. So first of all, there's 4 plus 3 plus 2 books. That's 9 books total. The probability of selecting a lit book would be, lit book is 3. There's 3 lit books out of 9 total. The probability of selecting an algebra book would be 4 out of 9. And again, these are mutually exclusive. Nothing is in both categories, so I just add them together. 3 out of 9 plus 4 out of 9 is 7/9. Can't be reduced, so that's my probability, 7 out of 9. Number 9, this is a fun one. So now we're looking at a bingo card. And in the game of bingo, you've got 5 columns that are labeled with B, I, N, G, and O. Inside each of those columns, there's a group of numbers. So the B has 1 through 15, I has 16 through 30, N has 31 through 45, G is 46 through 60, O is 61 through 75. We are looking for the probability that a number is a multiple of 4 or is in the O column. Multiple of 4 or in the O column. So first of all, we know that there's 75 total numbers because they go from 1 to 75. Okay. Second thing, we need to know what are the multiples of 4. Well, if I start with number 1 and I go through my multiples of 4, that means I'm looking at 4, 8, 12, 16, 20, 24. I'm just looking at multiples of 4 here. 28, 32. After that, 36, 40, 44, 48, 52, 56, 60, 64, 68, and 72. If I go to 76, then I'm off the bingo card because 75 is my biggest one. So let's count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 multiples of 4. Okay, next thing, I need to know what's in the O column. In the O column, I have 61 through 75. That's 15 numbers. 15 numbers in the O. And then the last thing that I need to know is what overlaps, or do any overlap? Well, I'm looking from 61 through 75. So if I look at the numbers in my multiples of 4, 64 is in there, 61 through 75, 68 is in there, and 72 is in there. So let's take a look at how we would figure that out. I have to take the numbers that are in the multiple of 4 category, that's 18 out of 75. And I have to add to that the number in the O's, that's 15 out of 75. But I have to take away 1, 2, 3, because there's 3 in both. Okay, so that's minus 3 out of 75. And by the way, that means these are inclusive events. If I add those together, 18 plus 15 minus 3, 18 plus 15 minus 3 gives me 30 out of 75. I can reduce that. If I divide by 5, I get 6 out of 15. I can even cut that again and make that 3. Nope, can't cut it in half again. So that's just going to be 6 out of 15. All right, I want you to, oh yes I can, 6 out of 15, divide by 3. Duh, I knew there was something I was missing. That means I have 2 out of 5. There we go. That's what I missed. All right, I want you to pause the video at this point and see if you can finish number 10. Finish the question in number 10, decide whether they're mutually exclusive or inclusive, and find the probability. And don't forget, at the very end, you need to go back to Schoology and take the quiz. Have a great night, and I will see you tomorrow.